Welcome all of you to Animaths. Now this is the third part of factorization that we are going to take up in this video. Now we had done two earlier parts of factorization. We have taught different methods. This particular one for factorization will be done only with all the factorizations here will be done only with difference of square method. That is, we shall be using the formula a square minus b square is equal to a plus b with a plus b into a minus b. Okay, so we are going to use that formula throughout for all the sums in this video, because I had to make a separate video as I had promised in the second video, because there are a bit too many types of questions based on this particular identity. Okay, so I am telling you once again, you will find all the links of all the videos in the description box. That is, all the parts of factorization in the description box. Okay, so let's start with it then. Now here is the first question, which says, let me take up the very first one, a cube plus 2a square. Okay, which says a cube plus 2a square minus a minus 2. Now if you see this question does not look like splitting the like a difference of square sum. Okay, it does not look like a square minus b square sum. Now what is the identity we are going to use? Let me write that also. So we are going to use this throughout, as I said. This is what will be used throughout in this video. Okay, now how do we do this sum? As I said, it doesn't look like a square minus b square question at all. Okay, so let's see. Here we'll just group them. So here, if I take between these and between these, we shall be grouping them. Okay, so here we'll be taking a square common, and then we have a plus 2, and here take the minus sign common, and we have a plus 2. Take the a plus 2 common, and we have a square minus 1. Now the sum does not end here. Okay, generally you all might think that the sum is going to end here. The sum does not end here. As long as we have a difference of square like this, okay, we have to keep doing the sum. So here we have a plus 2, and then as long as we see a difference of square like this, a plus 1 and a minus 1. Here I want to tell you, if you don't see anything here, that means there's a 1 here. So you can always consider a 1 over here. So this is a plus 2. From this one I get a plus 1 with a minus 1. So this is where we have used this identity, that is the difference of square 1. Let's take up another question, which is slightly different. 4a square minus 4b square plus 4bc plus c square. Okay, so how do we do this sum? Now here if I see this particular question, it is already given, this part is already given in brackets like this. Okay, now what to do? This, if you look carefully, it is very important to observe the question in factorization. If you look carefully, this is actually a perfect square. You can use a plus b whole square for this part. So I can write it like this, minus 2b plus c. Okay, because you see 2b square, c square, and 2 into 2b into c. So this is my, okay, so I have written this whole bracket as a plus b whole square form. Now once I have written it in the form a plus b whole square, I can see that a difference of square has been created. So 2a plus 2b, this is a plus b in one bracket. In another bracket, 2a minus 2b minus c. Okay, we cannot factorize beyond this. We cannot go beyond this, because these are all unlike terms. So we'll have to stop here. So this is my This is the second sum there, and it's the second type. You see, here we took common and then we got is difference of squares. Here this was given in the, actually it is the expanded form of a plus b whole square, so we had to get it back to the square form and then use this identity. Okay, so this is as I said, this is another type. Let's take up another question which is very different, and I really wanted to do this sum for you all. X square plus 1 by x square minus 11. This is the question. Okay, now this does not look like any identity at all. You will not be able to fit this into any of the identities. What to do? Okay, so what we can do is, very cleverly we will just copy this part. Okay, we just copy this part. Here this minus 11 can be written as a minus 9 minus 2. This is from integers. Okay, so minus 11, I first write the minus 2, then I write the minus 9. Then I concentrate on this much, okay, which gives me x minus 1 by x whole square. Okay, if you expand it, you are going to get this minus 2, because the 1x and 1 by x cancels off, so it gives you a minus 2. Okay, so this is the reciprocal type of expansion, minus 3 square. Now you have to be very careful to use a minus sign here, because the 2 has the minus. If the 2 has the plus, then you should use the plus here. Okay, so x minus 1 by x plus 3 and x minus 1 by x minus 3. Factorization done. Okay, this is the next question, which is almost similar. 4x square plus 1 by 4x square, and then a, okay, after that a plus 1. Now this also does not fit into any identity. What we can do is write it like this, okay, and then put a plus 2, because my expansion requires a plus 2. I have added 1 to it. I can't do it in any expression. Okay, I can't suddenly add 1 simply because I need it, so I will take away 1. So on simplifying this, I get back my plus 1. Okay, so now I have 2x plus 1 by 2x whole square. This is here to here. I am not putting a bracket, but here to here gives me this. Okay, if I bring it to the square form, and minus 1 square. So that gives me 2x plus 1 by 2x minus 1 a minus b, and 2x plus 1 by 2x plus 1. Many students ask me, can we first write the plus and can we later write the minus, or first the minus later the plus? The sequence does not matter. Okay, because as long as we are doing a product, if we have 2 into 3 or 3 into 2, it does not change your answer. So you can write a plus here, minus here, or plus here, does not matter. So this is my final answer. Let's take up one more question based on this, the same identity. Now this actually is a very tough question. Very few people actually are able to do this in the exam unless you know it from before. Here, this question. This one, if I see closely, it is this plus, okay, then I have my x square. Now this is not coming, 1 can be written like this. What if I make it a 2x square? Okay, if I make it a 2x square, then it looks like an expansion, a plus b whole square minus, okay, minus how much? Minus x square. Okay, because I have given it one extra x square here, so I have taken out that x square here. I gave it one x square, so I took out one x square. Now x square plus 1 whole square from here to here gives me this minus x square. Okay, now that is, this is my a and this is x is my b now, not x square. X square plus 1 minus x, that is a minus b, x square plus 1 plus 6, that is a plus b. I can also write it like this, plus x, sorry, that is a more systematic way, and okay, so I can write like this. So it is the same thing, only thing is I shifted this here and I shifted this one here. So that is my answer, that's my final answer. So these were few questions, all of which were based on a plus b, a square minus b square. Okay then, so that's it for today. If you have liked the video, do not forget to like, share and subscribe. Thanks all of you.